Imagine a star, not just any star, but our very own sun. Now picture it erupting with unbelievable power. A massive burst of energy explodes from its surface, dwarfing any solar flare we've ever seen. This is a superflare, a cosmic event of incredible magnitude. Superflares are like solar flares on steroids. They release 1,000 or even 1,000,000 times more energy than a typical solar flare. These events are rare, but their power is awe-inspiring. These enormous explosions can stretch for millions of miles from a star's surface. They hurl massive amounts of radiation out into space at incredible speeds. If a superflare were to erupt from our sun, it would be a sight to behold, but it would also be a cause for concern. Superflares are important to study because they can have a significant impact on planets orbiting nearby stars. The intense radiation from these events could strip away a planet's atmosphere, leaving it barren and lifeless. Imagine Earth being bathed in the searing energy of a superflare. Our satellites would be fried, our power grids would collapse, and life as we know it would be in jeopardy. Understanding superflares is crucial to understanding the potential dangers they pose to life in the universe. But superflares are more than just destructive forces. They also provide valuable insights into the inner workings of stars. By studying these events, we can learn about the magnetic fields and energy generation processes that occur within these celestial objects. Observing superflares is no easy feat. For centuries, these events remained hidden from view. Early astronomers relied on their eyes to study the heavens, and superflares, being relatively rare, were simply not observed. The invention of the telescope in the 17th century revolutionized astronomy. Suddenly, we could peer deeper into space than ever before. But even with these new tools, superflares remained elusive. They emit much of their energy in wavelengths invisible to the human eye, making them difficult to detect. It wasn't until the 20th century, with the development of radio and X-ray astronomy, that we began to truly understand the power and prevalence of superflares. These new technologies allowed us to see the universe in a whole new light, revealing the hidden energy of these cosmic events. Section 4. Unlocking the secrets of superflares. One of the key milestones in superflare research came in 1994 when astronomers observed a massive superflare erupting from the nearby star EK Draconis. This event, captured by the Japanese satellite ASCA, provided the first detailed X-ray observations of a superflare. The observations of the EK Draconis superflare confirmed that these events were far more powerful than anything we had ever seen from our own sun. This discovery sent shockwaves through the astronomical community, forcing us to re-evaluate our understanding of stellar activity. In the years since, we've made significant strides in our understanding of superflares. The Kepler Space Telescope, launched in 2009, has been instrumental in this effort. Kepler's mission was to search for planets orbiting other stars, but its sensitive instruments also allowed it to detect the subtle dimming of starlight that occurs during a superflare. Section 5. The Universe and Us. The Kepler data revealed that superflares are not as uncommon as we once thought. In fact, it appears that many stars, including some similar to our own sun, are capable of producing these powerful eruptions. This discovery has profound implications for our understanding of the universe and our place within it. The study of superflares is still in its early stages, but we've already learned a great deal. We know that these events are incredibly powerful and that they can have a significant impact on planets orbiting nearby stars. We've also learned that superflares are not as rare as we once thought, and that even our own sun may be capable of producing them. These discoveries have ignited a new wave of research as scientists strive to unravel the mysteries of superflares. By understanding these events, we can better comprehend the evolution of stars, the potential habitability of planets beyond our solar system, and the vast interconnected nature of the cosmos.